Good morning, class. Welcome. I mentioned the day before that today we'll be solving system of linear equation by a method of graphing. I had mentioned that we can solve the system of equation by various methods. We can do them by addition, by elimination, by substitution, and so on. But graphing is very important. It gives you a visual perspective of the solution. Before we graph the system of linear equation that I have on the board, and this is that equation y equal to x minus 5 and y equal to minus 2x plus 4, the system of equation, class, is stated in slope-intercept form, which makes it a little bit more easy for you to graph, because by looking at the equations there, you are able to know the slope for each one of those equation, for the line for the equation, and also you know the y-intercept for each graph. Now, before we go, let's mention three cases that exist with these systems of linear equation. We have a condition where we can say that the system is consistent. When the system is consistent, then it has at least, an equation has at least one solution. If you have a situation where the system of equation is inconsistent, well, in that case, you don't have any solution to it. And then the third case is where we have the system of equation may be dependent. If it's dependent, then in that case, you will have infinitely many solutions to the system of equation. And that is a case that would be indicative of where we know that y depends on x. As x changes, so does y, because y is the dependent variable, x is the independent variable. And this would be a situation where both equations have the same line, same slope and same y-intercept. So you have infinitely many solutions. As x changes, so does y. Alright? Now, since you have an understanding of those three cases, we can go ahead and solve this problem by graphing and see which one of those cases satisfy. Now, let's look at this system of equation. The easiest way to graph a system of equation here would be to find where each one of those graphs, where each one of those equations crosses the y-axis and the x-axis, or the x-axis and the y-axis. That is, finding the x-intercept and the y-intercept for each one of those equations, and then draw the line through those intercepts. In doing that, you will get a graph, and the solution would lie wheresoever those two lines cross. Where those two lines cross, that particular point would be the solution for the system of equation. So let's go ahead and do that in this case. Here, our first equation is y equal to x minus 5. And since it's already in slope-intercept form, we know that negative 5 at the back here, that is the y-intercept. So right away here, we know that this line here crosses the y-axis at minus 5. But if you didn't figure it out that way, you could have go ahead and set x equal to 0, because all along the y-axis, x is equal to 0. All along the x-axis, y is equal to 0. So if we set x equal to 0, then y equal to 5, because x is 0. Now, that is the same. Y is equal to minus 5. Y is equal to minus 5. That is the same point we have here. So we already find one intercept, which is the y-intercept for the first equation. Now, to find where it crosses the x-axis, we'll set y equal to 0, and that will take us along that line here, the x-axis. And if y is 0, then x equal to 5. Y is 0, then x equal to 5, because if we add 5 to both sides, this 5 will be eliminated, and x equal to 5. So x equal to 5 is here, and class, that is your x-intercept, where the line crosses the x-axis. Now we'll go ahead and join these 2 points. We join them, this is what we get. Let me extend it a bit at the back here, and this is y equal to x minus 5. So we finished one of the graph already. We'll do the same thing for the next one, y equal to minus 2x plus 4, and then if x is 0, then y equal to 4, and this here is the y-intercept. If x is 0, y is equal to 4, and that is going to be up here. So we have there, class, the y-intercept. Now let's find the x-intercept, and we'll find that by setting y equal to 0. If y equal to 0, then we get minus 2x plus 4 equal to 0, and this implies that 2x equal to 4, which implies that x equal to 2. So we get that? This minus 2x, you can bring it over here. So then, x equal to 2 is this point here, and that is our x-intercept for this one. So let's go ahead and join them. So if you join this, extend it a little bit at the back here, this is what we get. And this is the graph for y equal to minus 2x plus 4. And this is where they cross. Now, this graph may not be drawn to scale because my unit of measurement might be a little bit off. It's a rough drawing. And it appeared to be where x equal to 3, y equal to minus 2. So I would say that my solution would be that ordered pair, x equal to 3, y equal to minus 2, by this graph. So now, since we did a rough drawing here, it would be nice if we can go ahead and check this out. How do we do that? If that point, that ordered pair, x equal to 3, y equal to minus 2, if that is a solution to the system of equation, when we take those values and substitute them into the equation, we should get a true statement for each equation. And if we get a true statement, that means to say your solution is correct. If you get a false statement, then it is not correct. So let's go ahead and check that out here. Our first equation is y equal to x minus 5. Here, x is 3, y is 2. This is our solution. So then, if y is minus 2, then minus 2 is going to be equal to 3, which is x, minus 5. And negative 2 is going to be equal to 3 minus 5 is minus 2. Minus 3 equal to minus 2 is true. So that one checks to be correct. Now let us go ahead, class, and check this out. Our x is minus 2, y is 3. So then negative 2 is going to be equal to minus 2 times 3 plus 4. Minus 2 is going to be equal to minus 6 plus 4. Minus 2 equal to minus 2. This is true. So in both cases, we find that we get true statement and we are convinced that this is the solution by graphing. Now, class, there is more than one way of doing this problem. We have done it by graphing, but our graphing, we can do the graphing in more than one way also. Instead of finding the x and the y-intercept that way, we could have made two tables of values, one for each equation one for x minus 5 and one for minus 2x plus 4, and plot some values in there and find out if you have the same ordered pair exist in both equations. If you get the same ordered pair, our solution for each one, then it would have to be the point where those two lines cross. Each equation has a line, and the only place it would be where those two lines cross, and where they cross is the solution. So let's try. When x is 0, let's start with 0 here. This is going to be minus 5. When x is 1, it will be minus 4. When x is 2, it will be minus 3. And if x is 3, it's going to be minus 2. When x is 4, it will be minus 1. You can stop here. So let's do the same thing over here. Let's say we don't know yet what the solution is. So when x is 0, this here is going to be 4. When x is 1, this is going to be minus 2 times 1, minus 2 plus 4 is going to give us 2. When x is 2, this is going to be 0. Minus 2 times 2 is minus 4 plus 4 is 0. When x is 3, this is going to give us what? When x is 3, this is going to be minus 2 times 3 is minus 6, plus 4 is minus 2. When x is 4, minus 2 times 4 is minus 8, plus 4 is going to be minus 4. So here we see, we don't need to go further, we see that we have the same ordered pair class appear in both tables of values. The ordered pair x equal to 3y equal to minus 2, x equal to 3y equal to minus 2 are in both of them. And the only way to place that point would appear on both lines is where those two lines cross. And that's it, where they cross. So we are convinced more that that is the solution. So there is more than one way of doing the problem. And as we mentioned, we will solve more of these problems. And we'll also do systems of equation where we have 3 equations and 3 unknowns, which will be a little bit more complex than this. But this is not the only way of solving it, graphing. We also have ways such as addition, substitution, elimination. All those are ways to solve these systems of equation. And you need to know these or master them, so we'll do a lot of practice ahead. So, any question, class? Any question on the problem? So I will see you all next time.